Thank you very much. Appreciate that introduction. I've got $100 for you later on. Speaker introduction, who am I? I'm Don Murdoch, as Seth mentioned, author of the Blue Team Handbook, and this is kind of like my official announcement to say that yes, for the incident response edition, there is a 50-page update coming, and I can now actually do that because I've got this talk done, because I really wanted to get to the invoke command material part for that talk. Holder of many, many SANS coins, clinically addicted to Starbucks, Komodo Dragon, coffee, and spell check. IT, I've got gray hair, you guys can figure that out. Security since 2001. And I like to wander. So the very first thing I want to do as you're looking at this agenda is, why are we doing a PowerShell tutorial type thing at a Blue Team Summit? And there's a very good reason for that. As I mentioned last year, I run a cyber range at a university, Regent University in Virginia Beach. I have people come through for highly advanced education. We have students, we have industry companies, we run people through all kinds of stuff, interactive scenarios. Like I mentioned earlier, an industrial control scenario where you actually have to do packet decode to understand the actual case. It's very interesting. I've run at least 170 people through various events since I was here last year, and I've had 4 of them use PowerShell for analysis. That's 4. That's not good. So I suggested this as a topic, and we think it's a good idea to make sure that we get good baselines. Now, the slide deck is put together specifically for you to take home and use later on. I thought about doing interactive demos, and I realized this would take 3 hours to do all this stuff in a demo mode. So what you have is a slide deck with a cornucopia of screenshots. And the last thing I wanted to tell you is, if you were here at the summit last year, someone made a comment, and the comment went something like this: if you're not coding, you're a substandard stock. I'm just going to say it right there. Who said that? No, might have been Eric, right? So I hope that by the time we get done, at an absolute minimum, you're going to take one example from this talk and run it on your enterprise after you've deployed WinRM. So the very first thing I want to get to is, A, I'm going for best memes that I don't talk about, but B, when you have an incident and you're trying to go get data from your environment, what do you want to collect? What do you need to collect, and what methods are you going to use? Is it get a bunch of junior people and tell them to go RDP and make a bunch of screenshots? No. Is it go use your EDR agent? Well, gosh, we couldn't afford to deploy it everywhere, so we've only got it on half of our end users' workstations. Is it go ask your asset management system to do a query? Yeah, that takes 4 or 5 hours, and that's a job, and it has to run, and what do we do for disconnected systems, and blah, blah, blah. So it just doesn't work. So my hope is that by the time I finish with you, you'll be able to run invoke command across your enterprise, get some answers to some critical questions, maybe look and see what your Firefox is doing for its registry entries. I'll actually show you that. Changed that this morning based on input from Eric. So we've actually changed the talk during the day. This is an example of some of the things that you'll collect during an incident. The incident that you're going to need is all going to be variable. So I'll give you a framework and a method to operate from so you can go do more and more stuff on your own. Very first thing you need to do these types of things that I'm going to go through is a modern version of PowerShell. 5 and above is significantly preferred to go get stuff. There's a script that you can use to go get the Microsoft remote access tools out of the PowerShell gallery. For long-term development, you need a better editor than PowerShell ISE. PowerShell ISE is a basic editor. The one thing that's really nice about it, does have color syntax editing, which is extremely helpful. And the last thing on the lower left-hand corner there's a note, and it says create a share where you can drop stuff off. What is the kind of things you're going to drop off during an incident? You're going to drop off documented files. Now that's a term. When I worked at a Medicaid company, I was known. I'm a bit of a unicorn because I like to write. How many IT people like to write? Don't put your hands up, you know. But I like to write, and I would write good stuff. And they started calling these things documents, which was pretty humorous until I actually heard someone use it on a podcast, and I was like, oh my gosh. So I want you to think about documentation when you do any of the things we're going to talk to today. Produce activity and records that are self-documenting by time and date, and just how hard is that? Just how easy is that? It's a piece of cake. With PowerShell, you can go ahead and take the current date and time on that machine that was used to collect the data because you're going to run this command on a remote machine and get that machine name and drop it off on your share. So if you collected a bunch of data for a given machine, it will appear to you in natural sort order. Please also note that if you use the syntax that I'm advocating here, this is parsable. I can parse things out by parsing things based on that period boundary. So that will help you in the long run, the idea of whatever scripts you build that are producing some kind of output, just add a little bit of intelligence to it, and then you can have much better output. The second thing I want to make you aware of when it comes to PowerShell is you probably don't want the defaults of any one of the commandments they use. You probably want more data than that. Mike Poore is a colleague of ours, and he said, I always want more money. I want more money so I can get more data. I need more data so I can get more money. It's true here too as well. We want better data, we want richer data. So this is the syntax that you use for any given commandlet that you think may relate to the case to go figure out what properties and methods that syntax or that commandlet will give you, and then you can go literally and select the additional properties that you want. You'll see many, many examples of this language construct throughout the rest of this talk. Third thing is, as you dig into using PowerShell, you're going to have to dig into Windows Management Instrumentation, WMI. This has been around for a long time. It dates back to 1998, originally deployed on NT Service Pack 4. I'm sorry for all those of you who are shuddering in your boots. Just remember, Service Pack 4 was not Service Pack 2. Just remember that. You can go ahead and get data there. You'll see some of the things that I'll actually show you. The WMI function looks just like the PowerShell output. That's not necessarily a coincidence. There's a few articles talk about that, and there's a really, really nice GUI tool written in, guess what language this is written in? Correct. 1,253 lines of beautiful code that actually gives you a graphical user interface so you can see how to explore WMI. WMI hasn't had the best structure as it's been developed over time. Some parts have been very well structured, some not. Microsoft, when you go read about it, you find that they weren't like imposing restrictions on people. So I went through and pulled something out here, and I know it's hard for you to see, but on the lower right-hand tab, I pulled some tabulated data of TCP networking data activity. There's a modules tab that you can actually use. And if you click on the module tab, it will show you some PowerShell code to go use this. Now again, every single thing you see here is in the slide deck, so when you go get that off the Summit archive, you'll be able to use this tool, because I'm moving at a breakneck pace. Here's an example of pulling data from a WMI call, which looks a whole lot like the native PowerShell commandlet function. So there's a number of PowerShell functions where they give you a quick, easy way to get data, but it's actually using WMI under the hood. Second thing you need to be aware of, or the next topic here, is different data will be presented in different formats, and you need to think about the long-term data consumability. I made that word up just for this talk. The consumability of the data. Which is more consumable to you about disk drives? A huge long string of bytes or the gigabyte size or free space size? Which are you going to work with? Different commandlets and ways of retrieving data will give you different pieces of information. You may actually want the highly exact data on the upper right-hand side because you may want the total number of actual bytes. You may be working a forensics case, and that may make a difference. You may want the more easy-to-read data on the lower left-hand side. So it really depends on what you're going to get. Your mileage is going to be a little bit variable when you use these various tools. There's a common pattern that you will see when we pull data with PowerShell, because we don't necessarily like the native header or the native field name, or I should say property name. It's really what it is. So what I have here is some syntax where we did some particular math. We actually took the size value and we divided it by 1 GB, which is a reference to a gigabyte. So we got the total size in gigabytes and the amount of free space in gigabytes. And we used very specific syntax so that we could get a more meaningful column header. That's examples of how you can take the native data that the commandlet returns and change its format a little bit so it's more meaningful for you for the case that you're working on. It's really important to note that when you start learning and playing around with this, the order of the squiggly bracket makes a significant difference. You can very easily get that wrong. Any syntax highlighting editor will help you get those in the right spot. What operating system are we using? If you run this particular commandlet on the top, you get over 70 properties. We probably don't want all 70 for our case. We may want a subset. So here's an example of pulling a subset. You'll notice that this subset actually uses a star for some of the property names because it pulls off all the build whatever, and if there's a couple of things that begin with build, it will pull those out for you as well. Users and groups. How many users have been created on the environment? You ever had an incident where someone created local users on a server? I have. Have you ever had an incident where someone created a username on a machine with a $sign at the end? What's a Microsoft account name with a $sign at the end? And no, Mike from Microsoft can't answer. It's a computer name. This is one of the ways that you can actually detect that by just pulling that information. You can pull users, groups. I like to pull the security ID field for everything that I use because especially for local user accounts, the security ID field is specific to that machine if it's a local account. The security ID will be consistent across Active Directory itself. So again, there's different ways to get data. What about if you want to go see what changes have occurred on the system in the last day or two? I was actually preparing for this talk and I copied a bunch of stuff over to my laptop. And you can see there I created a directory where I copied a given exe to the system. So there's ways that you can do this. And please note, I am using this tool. It's called Excel to look at this comma delimited data. You too can be data analysts. You can even make a pie chart of that if you want. Just pull out the directory name. What percentage of things are not in the Windows directory? And so you can do things like that with using Excel. But we don't want the registry to be left out. Let me point this out to you. Get child item. Get child item. PowerShell can treat the registry like it was a file system. Map it to a drive letter, explore the components in the registry, pull information out. It's a similar metaphor. There's a number of other ways PowerShell can do this. This is a very useful technique because you could go ahead and scour the run keys. So you could actually create a script with what I'm showing you today. This is 3 lines of code to map a drive to a machine. You could create a script to go pull out the run keys of every system on your environment, probably Monday morning by about 10 o'clock because it takes 2 hours to turn on Windows Remote Management. So once that's done, you could go do that and pull the run keys and do long tail analysis on the run keys. I will show you how to do that later on. Current logon sessions. I can go get that. Sometimes this data is not well formatted though. I'd like to know how many of you know what a login ID is by that number. I can't do anything with that. First, it's local to the machine. Second, it doesn't tie to a security identifier. Third, it certainly doesn't tie to a SID. So that's an interesting piece of artifact on a given machine, but not something I can use, and certainly not something I can put in a repository and search for later on 6 months from now. Login IDs are useless. But wait, can't I actually go get the system user? There's several methods to do this. Here is one method, and you can go get the current logged on user, so maybe I should connect those dots. And this is a little bit more complex. So here what we're doing is we're pulling, what do we got here? We've got the login session data. We're taking some of those parameters. We are mechanically constructing another supplemental WMI query, and then we're going to go ahead and use that to pull the username on that particular system at that given date and time to see who's actually using the system with a piece of information that we can actually use, an actual username. You'll notice again here that I changed the column headers, because normally you'd get this thing called caption. And I actually have a screenshot later on, and it says caption specifically so you can see just how awkward that is. Basic process information. Process information, highly valuable. What processes are running on a system? You can go ahead and pull this data. You can reach out there and say, I want to go ahead and get this information. I gave you some other examples. How many processes are running? It says 189 there. If you sent this to a file with headers like comma delimited data, just remember you have to subtract 1 because you have a line for the header. So there were 188 processes on this machine that ran. So you've got a way to get the count and a way to get that information. You can pull data and then get the command line information out of Win32 process. So here what we're saying is let's go ahead and pull the process ID, the command line, the executable, and some other attributes information. I can pull that data and get that out, because we're going to dig a little bit deeper with this So the next question is, if I can pull the process information, can I pull the parent process ID, and can I make use of that parent process ID? And the answer is yes. If you collect all of this data at one time, and what you see here in the top for loop is some rather complex syntax, but the complex syntax is doing something very simple. It's building what's called a hash. A hash is a computer science concept. I grew up on hashes because I learned to program in Perl back in the earlier in my life. Earlier. It was a number before 2000. And what you have with a hash is this concept of a key value that has to be unique. Excuse me, an index value that has to be unique. I should use the right word. And then your key value can be just about anything, and it can be free-forming. So if you have an index value, what is a natural construct for index values for processes? The process ID field. So I can pull that out. You'll also see there's a little syntax where you're going and getting the process owner. You can only collect that at that time in that login session because that's very volatile data. Once you shut that machine down, that ownership goes away. So I pulled off and I made 4 specific hashes with names that kind of give you an idea of what they're used for. And once I have that, then I resort the list. I'm going through in process ID number order because I sorted it. And I'm pulling out various pieces of information, the process ID, the name, the owner. Because I constructed a list that had the process ID and the parent process ID, I can then use the process ID to go back into my original list and pull up the command line and the process owner of the parent process as well. You don't need no carbon black. You got PowerShell. Now, none of you go back to work and say, yeah, they showed me this cool thing, without me insisting that you function test your code. So I did that. Wanted to make sure that you guys know, here's an example. You should be doing this yourselves. Don't just trust the fact that, Don told you how to do this. Check it out yourself. I went and pulled out some process ID information. You can see that the parent ID of Chrome is 7008, I think, and you have a path and an executable and an ownership. And then you can see the child ID points to the parent ID. And if you looked at the child ID with sysinternals, you'd see all that big, long command line stuff. You can also see that Chrome itself, or himself or herself, itself, I guess it's an it. Its parent is Explorer that was invoked by that D. Murdoch guy. Gotta watch out for him, he's a pretty crafty guy. Unfortunately, I didn't have enough room to show you Explorer on the sysinternals screenshot because I wanted it to be readable. But you should always check and validate your tools because if you're gonna do things in a scripted fashion and you're gonna run it across 5,000 nodes in your enterprise, you wanna know it works. So the 5 or 6 minutes it took to do this, I thought was really worth it to encourage you that as you use these tools to always check your code. Well, we've talked about attributes of processes, directory structures. I can go search that. I can go search the company name. I can go search and see, are things in this given directory structure, but are they not from Microsoft? Because most of the time you're gonna find stuff from Microsoft in program files and program files x86. Here what you see is 2 examples of an NVIDIA card. NVIDIA card stuff running on the top, and in the bottom, I had to construct this and contrive it to make this work, because fortunately, when I ran this particular command on my test system, I didn't have anything running in temp. So once I figured out how to get something running in temp, and as an indicator, it's a common IOC indicator that things running out of the temp directory usually is not the best thing in the world. That's a tactful way of saying it could potentially be bad. That cognitive process thing that Steph discussed earlier, because her talk was great. I went and pulled that out and said, I want to see things that are running out of temp. So you could do that in your enterprise. Tell me everything that's running out of temp in our environment. Network addresses. You can get all kinds of network addresses, and here we have an interesting anomaly. What is a 169.254 address? It's self-assigned. Why does a machine have a network interface that's self-assigned? That's not a good thing. So from an operational perspective, that's kind of wonky. From an incident response perspective, we really want to validate the data that we collected from that given machine really is the IP address that we're looking into. Data from Windows event logs. I have a couple of different examples to show you how to do this. This technique is also used by Deep Blue CLI, another well-known IR tool to go out there and pull data for you. And as we go through this, first and foremost, you can go pull data with the structured XML interface. And here what this code does, and this is commented for you in the slide deck, so when you pull that down from the Summit archives, you can actually read it, type it in, and see what it's doing. Go pull out the attribute name itself and the text of that attribute. I chose a 4776 event because I wanted everything to fit on the screen. That's why I chose that event, not because it was a particularly good event or not, but I wanted to have enough small information so you could see the effect. So as we know, and I'll show you this in a minute, all the data is written with an XML layer on top of it. So you can go ahead and pull all of the event attributes and pull all that information out so that you don't have to go figure out which property or attribute you want from the event log. PowerShell will do that for you if you go ahead and ask the structure, what is the structure of this particular log file? Give me all of the data and give me the field names. The net effect of that, and this is a different way of producing PowerShell output. I'm a fan of the grid view. It's kind of nice. You get a spreadsheet-like. Unfortunately, here you're only going to be a filtering data analyst. You can't make a pie chart without grid view. But we can go pull that information out, and all of those column headers that you see going across were constructed by the XML library, pulling out the values for the data itself. And there's a drop down so you can build some filters. So if you pull 25,000 rows out, this is kind of like the auto filter feature in Excel. It's pretty neat stuff. Now, the real thing I want to peek into in the security log is all that cool, rich data that's inside of an event. The way actually every Active Directory, the way every Windows event log functions is binary data and date and time information and an identifier for which log name it is, all gets written into a binary structure at one time as the system is running and as the system is told to do some record keeping. You do not get that nice, readable information stored in the event log. What you actually get stored in the event log are individual properties. What happens when Event Viewer renders the log data, or when you go talk to the system over the network to pull the log data, is the DLL is invoked that's tied to the log type and the log source. If you've ever seen a message in the event log and it says something like, data could not be retrieved at this time because the DLL is not registered, that problem means that the DLL that's used to interpret and provide the plain text for you is broken, deregistered, or someone removed that application from the machine and the DLL went away, but there was still data in the event log. That's why that happens. So here you have a list of properties that are actually extractable. You have an interface to those properties, and I'm actually a real fan of this interface because this runs about 3 times more quickly than the XML interface from what I've seen empirically. There's another plus about it, and that is that I'm kind of forced to actually come up with my own column headers. So here the syntax you see is I'm going and pulling this data. I'm pulling out individual fields. As you see on this, push the previous button, these are all numbered. This is an array, 0 through 15 or 16, however many we have there. And I'm pulling these out in order. I pulled out the fields that I wanted in order from I don't care about all 17, I cared about 4 or 5 in this case. And I have data on the process name and the username and when it occurred. That's the time that the event log item was written in the event log, so that's something that you normally see in Event Viewer when you pull that out. So that's a very useful thing to do. You can take this, run this across every system in your environment and find out where a person has been logging in case your SIM is not functioning well for you, or more likely, in case you've turned your SIM on, but for some reason you're having a data collection problem. That never happens with SIM. No, they always work. Yeah. Been around a long time with that one. I did hear a laugh. There's a different way of pulling data. I wanted to give you 2 examples. You can go ahead and pull stuff out and search after the fact. There's a where clause in that second statement. We've retrieved all the data that's come across the network, and because we're right of pipe or right of the vertical bar, we're searching locally. And I pulled this out. You can see comma delimited output there. You can also see the out grid view. So if you don't have a more recent version of PowerShell on a machine, like say you're on a Windows 7 box and it hasn't been updated in 5 years, probably more like 7 years, since you only got PowerShell 2 or 3 on it, you can use this older method as well. So I wanted to make sure you had a couple of examples in the slide deck. So let's put this stuff together. Let's actually do something kind of useful, right? Let's go ahead and look at sysmon data. We're going to open up the sysmon log file, the operational log file, and this is you'll see this term when you learn more about PowerShell called filter left. At the point of retrieving the data, we said, we want stuff from the operational log, and I want a particular event ID from that log. I want event ID number 1. So what we're doing is we're pulling the list of commands, or excuse me, the process execution path, which is the path to the executable and the executable name. It's not the same thing as the command line with the command line arguments. If you want the command line with the command line arguments, you open up your viewer, point it to the operational log, count your number of properties. It's like 7 or 8. It's like 4 or 5 down on the list. So you could go get the full command line for the one of changing the array index in this function that I'm pulling. We go through, we look at the list, we say, is this item in the list? We check to see if it's in our hash. If it is in our hash, if it's not, I should do this in the correct order. If it's not in our hash, we add it to a hash, and then we set the counter to 1. The counter is the value key as opposed to the index key. If it is in the hash, we add 1 to the counter. So that's actually what's going on here. So we're getting a list. We're checking to see if the list is populated with that item. If it is populated, we're incrementing a counter. And then if it's not populated, we're going to add it to the list, and we're going to set the counter to 1. It's kind of like a Santa Claus effect. Check on the list twice. As you can see here in this output, it appears that Chrome is pretty popular on this particular system. To run this on my hexacore, I give you the times of how long it took to pull all the data in a 128 megabyte sysmon log. So that was what, 23, 24 seconds, something like that, to get these answers. Chrome is widely represented. So this is an example of what we call long tail analysis, or LTA. You may also see the terms MFO, most frequently observed, or least frequently observed, LFO. There is gold in singleton events in most data sources that you can look at, because when you have an event that occurs and there's a lot of those events, more often than not, it means something's running pretty well. Like Chrome obviously is being invoked on this machine. It can run. You have several other Windows processes that were running. You have a confidence in the machine is being used. You have all these singleton events down here, and there's things in there that looked interesting. I think there's something running out of temp. There's some really long strings in there. There's one executable that's longer than 130 characters. That's kind of fishy, you know? That's interesting. I don't know what that means, but there's lots of interesting data in those singleton events. Now, I did all that to get to the point of this talk. So not many people put their actual agenda slides 30 minutes in their talk, but here's the real agenda. I want you to be able to sweep the enterprise. Sweeping the enterprise means, from an information assurance perspective, when dealing with a case, can you query every single asset in your enterprise and find evidence of shenanigans? Shenanigans is a technical term. I hope that resonates with the audience. First thing is, can we hit everything? Second reason is, if we fail, can we detect a reason why? So here, we're going to ask that question. What are things that we can do? Investigate the enterprise. Look and see what's on the enterprise. We want to turn on Windows Remote Management. WinRM became on the market several years ago, really popular. It was like the hotness 7 years ago. You may be wondering for yourself, we turned that on, right? Well, I spent some time in an enterprise environment, Fortune 500, about a year ago. Not only did they not have command line record keeping for the 4688 event, it's been around in Windows since 2008 R2, they didn't even have that turned on. They did not have Windows Remote Management turned on. So yes, there are large organizations that have large IT shops that do not even use this facility. And they didn't have an EDR package either. So we're going to go ahead and sweep the enterprise, enable it, turn it on. By default, you have to be a member of the admin group. It uses Kerberos. You can, in fact, collect data from your islands. You know you have data islands out there. You know you have servers in workgroup mode. Anybody not have a server in workgroup mode in the environment here that wants to admit it? If you hit those boxes, the thing that is the most problematic is if a machine is in workgroup mode, it's not part of a domain. So the location awareness feature in Windows 2016 and 10 thinks it's on the public internet. Windows Remote Management does not listen to the public internet, so you have to change that attribute. There's a number of group policy objects that control how this works. Briefly, there's a number of really good tutorials. I put 2 of them in here. First and foremost, you have to enable it. And it says in the second bullet there in bold text, you can set the connecting IPs. Most people, when they turn on Windows Remote Management for the first time, is they put a star in that field so they can just connect to it, validate it, see that it's working, and then they tune that down so you can restrict access to it. And that's really what you want to do. For those of you investing the time and getting WinRM up and running, you really want to restrict it to some sources. That's important. A number of troubleshooting things. There's a couple of examples here of how to validate that the port is reachable, allowed through the firewall, and there's something actually responding. I put those in red for you, for very easy to see that. First and foremost, is the policy enabled? Did the machine get its policy? Is Windows Remote Management turned on? Is the firewall allowing the connection? Are you a member of the admin group? Those sorts of things. And when in doubt, if you actually have to go turn it on, the commands to do that on a target box like you'd RDP to it are shown there for you as well. You can also use the sysinternals psexec tool and psexec over to a box and turn on PowerShell Windows Remote Management by using these 2 commands on the bottom. You can actually do that, which is what we do for some of our range. What kind of things are recorded? What can you do to talk to boxes? There's a couple of ways. You can use commandlets that support the computer name parameter. There's a query of how to find that. I searched for that for all the commandlets installed. Tell me who has the computer name. Tell me who has the session name field. I can go ahead and use these, any function that has this. Here is an example of using a commandlet that supports the -computer name option, okay? One of the things to get out as you're looking at this slide is, as I talked to a machine and I pulled data from a machine, I get the name of the system as a columnar attribute that I get back. It's a property. If I pull data on 15 different systems and I pull one record of data, I get 15 different answers. So here, we actually use this to discover that the vendor who'd helped set up a bunch of computers had left accounts on the machine that were not accounts that we were aware of. So this is actually a real-life thing that we actually use this in our lab. Have to have a slide somewhere to show you how to get help. There's a way to do this. You can go get help on just about anything you want. It's a very nice facility. You can go get help and see if things match a given name to see what's available for disk or what's available for network. So you can go ask PowerShell what it knows about something. You can use one-to-one remoting. One-to-one remoting is when I use the PS session capability and I talk directly to your box and I go to your machine. Windows Remote Management has to be set up. You'll notice in the lower left-hand corner in the blue text, the word localhost. The line above that, I actually went using localhost across the network back to the machine. You could use your own PC name if you want to. You can go from another server in the network. You will get prompted for credentials. There's a number of things you can do one-to-many functions. Talking across the network, the invoke command is the way to do this. If I want to go talk to a number of targets, even if I listed the target twice, I get the answer back and I get the PS computer name variable so I can pull that information back. Again, I wanted something short to show you so I could get that all on one slide to see this is a way of pulling data. That string can be as long as you want to go talk to individual machines. Can you talk to a CSV file? Yes, you can. I showed you this Excel thing. You may have heard of it. It's been around for a while, spreadsheets. How many things actually give you data in a CSV file that could include a list of computer names? Lots and lots of things do that. I hear Splunk has a CSV export. Could be wrong. Maybe we can check with the Splunk guys. But if I got a list of computers, I could go ahead and then open that particular thing up, file up, go pull out the field that has the computer name in it, use that, construct it, send off my command, and get my results set. So that's one other way of doing this. Filtering things from Active Directory. We really want to, why should I go create a manual text file when I can go ask AD? Shouldn't everything be in AD? Yes, except for the data islands, and you know you have them. So here we went and we said, go ahead and, by a given filter pattern, construct a list, go out and ask the network of things from the Active Directory. We had to expand the name field. Be aware that as one commandlet sends data down the pipeline, things the right of the pipe character. Sometimes they send an object, or actually most of the time they really send an object, but here we had to go pull out the name parameter because the invoke command expects an actual name. What happens when things don't work well? This is in marketing term. This is a hook for a future slide. But I wanted to show you, here's something real practical. When I mentioned earlier something in your enterprise that you probably care about, I liberally borrowed this from Sec 555. The idea is that you can turn on auditing for all USB interactions when anybody sticks a USB drive into the machine, even if Windows has already seen that USB drive before. You can actually record that, so every single USB insertion, you can get a record of that. So this is an example of, we wrote a simple PowerShell script, and I'm going to go ahead and run that in the enterprise. I'm going to invoke that across the machine, and I'm going to run that script everywhere. Of note, please realize that invoke command limits itself to 32 connections at a time to control resources. If you have 1,000 machines, it may take a few hours for that to run if you use this method. You can also, something else you can kind of do, your mileage may vary on this one. I'm just thinking. If you find out and you did WMI exploration and you determine that that process has a method like the operating system function has a reboot method, if you wanted to reboot the environment, you could do that with 2 lines. It may cause some shenanigans, don't know, but you can do that. And if you want to sweep the enterprise, I wanted to give you some numbers. How long does it take to actually do this? So first and foremost, how big is our problem? It's very easy for you to find out how many users you have, how many groups you have, and how many computers you have. But that's really not the answer you want. You really don't want to go after the stuff on the upper right-hand corner of the slide. You really want to go after current systems that are actually responding in the directory. That's a little bit more peel back the onion. So let's go ahead and do that. First, let's figure out, are there disabled accounts? Yes, there are. So we're not going to be querying 205. I think we're going to query a couple hundred, a few less than that. Are there disabled machines? We can ask that question. Next thing you want to think about is, how do we make that data more actionable? What is an attribute that we can ask of our directory about a machine or a user to see if they've used the environment recently? We can ask for the login time. So in here you have these login times. What does a login time of 1600 means? It means it's never logged in, or the computer is at a Renaissance fair and it's listening to bagpipes and hammered dulcimer. That's useful. Part 2, you have the numbers. What does it take to do an ICMP query across the enterprise for, what I say, 2,251 machines? How do I go talk to that? Can I ping it? Can I get an answer? And I had to rerun this and realize, because I didn't actually count failure to responses. Responses that failed. I don't know what a failure to response is, but you probably figured that one out. I shouldn't be nervous. So we go ahead and test a connection. This is a simple ICMP query. This is a little bit VB scriptish because I really wanted to have output that you can use and put in a spreadsheet later on, maybe give to someone else. We ran a query. We should be able to talk to 900 machines. We can only talk to 300. These are all the machines that did not respond, and I have evidence of that. You can increase the timeout if you want, and this is an example of something that looks for the results. If you get a result, tell me you got there. If not, then don't. What does it look like when Windows Remote Management does not work? You get this beautiful, informative red message that tells you, I can't get there from here. Well, I want to do something about that. So in the last few minutes, I want to talk with you about the try-catch exception block. In the world of computer science, we pretty much figured out, probably about the time I was graduating, again, gray hair, that software generates an exception. Anybody ever experienced this? Little message on the screen, unrecoverable application error. That's a Windows 3.1 thing, for those of you old enough to remember, a UAE, or Windows 98, something like that. So here what you have is a try block and a catch block. A try block says, hey, look, operating system, this is a critical transaction, wrap this transaction, see if it runs. If it doesn't run, or it generates an OS error, handle it gracefully. And handle it gracefully means go to the catch block and do what's done in the catch block. Don't segment fault or crash or bail on the end user. So this is what it looks like when WinRM works properly. You get a nice message back. Here we have a try-catch exception block, and we have the error action stop, which actually lets the function work, because there's 2 different ways that you can You can have terminating transactions in PowerShell. You can have a non-terminating failure and a terminating failure. You want to cause a terminating failure. So if you're trying to run code to do invoke command and you keep getting these messages and you don't know what to do about it, you go forward and you pull down the deck and you say, oh, we need to do an error action stop so I can actually catch it in the exception block, and then I can handle that message and have some output. So last slide, where do you go from here? Many, many people have developed frameworks for you using all of the techniques that I've gone through, and they've created some really well-developed code sets to go and examine systems on the enterprise. But they have a different bent. Like Kansa is really good at looking over the enterprise and saying, you have all of this data, how many things do you have from a long-tail analysis perspective? There's other things that are specifically designed to go collect certain incident response data. This is a list of a variety of frameworks that have been around for a while. People talk about these. These are things that people actually use to pull data out. So there's a list for you when you get back to the office. And with that, I believe I have reached my time.